Now, usually before I start talking about exponential function, I start by, because I want people to think exponentially, because most of us think linearly, meaning what? Here's that bottle of water. If I said to you, inside this bottle of water, I have a bug, one bug. And every minute, that number will multiply. So in 1 minute, we're going to have how many? 2. In 2 minutes, we'll have what? 4. In 3 minutes, we'll have 8. If it takes 1 hour to fill this to the top, 1 hour, how long would it take it to be half full?
It takes
How much?
You said it takes
59 minutes.
That's it. Most of you are thinking 30 minutes. 1 hour to fill it, half of that, half the time. But it's not. Because 59, the next minute is going to double that. So it fills it. So that's how exponential function. They're not linear. Just because it took you, I'll give you another example. Money, because I know everyone likes money. If you can get 10% interest rate, which is a stock market, that's not strange. If you can get 10% return on your money should double. You'll see that better here. Every roughly 7 years. It's actually 6.93 years. We'll do 7 years to be on the safe side. Huh?
I said, who's investing your money for you?
You know what? If you actually put your money in the stock market for the past 20 years, 30 years, you probably have about 12% average over the last 20 years. Maybe this year is not good. I can tell you last year was over 28%, 30% return on some of that mutual funds. But, so watch what happens, because that's really exponential function, the way of looking at it. Imagine when you were born, this is when you were born, Grandma put 5,000 for you. I said, you know what? I'm going to put 5,000, my grandchild here. So when they're ready to go to college, they can enjoy it there. So she didn't tell you about it. Well, you're just born, so you have no idea. At age 7, you will have what?
5,500.
10,000. Double your money.
Oh, double right.
Every 7 years. So let's say Grandma died. Poor Grandma, don't remember anything about her. You're 7 years old. You don't remember anything. That money sat in the bank now. At age 14, you'll have what? 20,000. At age 21, you have what? 40,000. You can get a brand new car with it if you knew about it. But you don't know because Grandma's dead. So you had no idea. 28 years old, you have 80,000. 35 years old, because that's 7 years later, you have what? 160,000. It took 35 years to make 160,000. But watch this. It takes 7 more years to make another 160,000. So it's not linear. So now you have what? 320,000. At 49, you have 640,000.
Every year you're making double what you make.
Every 7 years.
Every 7 years.
Yep, your money will double. At 56, you have $1,280,000 sitting there. 7 more years. At 60 what? 63. Now you're thinking about retirement, but I can't afford to retire. Social Security now say you got to work till you're 70 years old to get Social Security. They want you to wait. So you said, I can't afford to retire. Age 70 now, you go, I'm going to retire now. And you start collecting Social Security.
5 million.
You have 5,100,000. Is it 20? So now it's at age 70, he goes, I got to retire. This job is killing me. But I don't know if I can retire because I can't afford to live on Social Security. Now because you're over the age of 69 and a half, Uncle Sam says, we need to get our money back from you because now they're going to collect on that money. Every time you take it out, that's income. You will get a letter in the mail at age 69 and a half saying to you, you must, not you'll be nice, you have to start taking money out of your retirement because they want their portion. You go, what money? The money you have at Bank of America. I don't have anything in Bank of America. You walk in and say, they told me I got to take my money, so I'm going to close my account. I'll take the money cash, please. What? Cash.
20s.
You have 5,120,000. It took how many years to get to that? 7. Now imagine if you plan for retirement. You say, I don't need the money. If you let it sit for 7 more years, at 77, you're going to make another 5 million. It took you 7 years to make 5 million, but it's going to take you 7 years to make now 5 more. You have 10,240,000.
That's if grandma's put
Yeah.
5,000.
I don't need it. At 84, you have what? 20,480,000.
The IRS.
I guarantee you right now, your kids are putting blue stuff in your water. They want you gone. They want their portion. Like, Dad, when are you dying? Come on.
The IRS would be
You know?
your ass with that.
But that's a $5,000 investment. Exponential function do not grow a straight line like you and I used to seeing.
Is that compound interest?
Yes.
Yes.
Yep.
Yeah, but it doesn't count for inflation,
No, that's true.
the worth of the dollar
That's true.
Yeah.
84 years ago.
Because 20,480,000.
I can tell you 5,000 about 84 years ago, you could have bought 2 homes and a car with that.
Easily.
You know?
Yes, but
If they had cars even at that time, I don't know.
when you're 84, you're that much money's gonna be worth $5,000.
It'll still be worth.
It'll be
Still.
worth a little more than 5,000.
So what exponential function look like, if you were to graph, and we're going to do that in a minute, they will look like this. And it keeps growing. It doesn't actually level, it keeps going. So we're going to graph a couple of these exponential functions and show you the graph for them. But that's what exponential function is. Not a straight line like this. That's called linear. Like, for example, if you buy a car, the IRS lets you deduct, let's say the car is, you bought a nice car for $60,000, you have a business, and the IRS says, we believe this BMW is going to be worth in 5 years. What is that BMW worth in 5 years? 12,000 in 5 years. It's going to be worth $12,000. So the IRS says we have something called straight line depreciation. And the way they figure that, they take the 60,000, subtract from it 12,000, what it's worth at the end of 5 years, and divide it by 5. So every year you get to deduct that much from your tax, always the same amount. The value of your car will go down at the rate, if you do the math with that.
That's 48 over 5.
What is it?
48,000 over 5.
48,000 divided by 5, yep. 48,000 divided by 5. So every year you get to deduct $9,600 from your taxes. Or the value of your car will go down, that BMW. So when you buy it today, $60,000, before you leave that showroom, a month later you go to trade in and go, oh, this car's been used, It's a year old now. Subtract 9,600 from it. It's worth what? 50,400. Another year later is going to be worth what? Subtract another 9,600 from it. So every year the value will go down. That's a straight line. That's not exponential. Exponential is different. Exponential is like that. More and more and more. So let's see if the exponential function really looks like this or not. Usually exponential function has the equation that looks like this. Y equals, I'll give you one example. Let's say, for example, 3 to the x. That's an exponential function. X now is the exponent. In the past was x cubed. X was in the bottom. The exponent was a number. Here, the exponent is actually x. So what does the graph of that will look like? Well, to graph it, we can make a table. We go x and 3 to the x. If I choose a 0, what's 3 to the 0?
1.
3 to the 0 is 1. If I let x be 1, What's 3 to the 1? Is 3. If I choose 2, what's 3 squared? 9. Now let me pick some negative value. If I pick a negative 1, what's 3 to the negative 1? Yes, that's 1 over 3 to the 1, which is 1/3. If I pick a negative 2, that's 3 to the negative 2, which is what? 1 over 3 squared, which is 1/9. Again, what I'm doing for a negative exponent is this rule. A to the minus n is 1 over a to the n, if you remember that. So if you go and find these points and try to graph them, you go 0, 1, right here. That's 0, 1. 1 and 3, be right here. 2 and 9, I need a ladder there to reach it, up there. 1, negative 1 and 1/3. Negative 2 and 1/9. And you can see when you connect these points, they're not going to be a straight line. They'll never be a straight line. Yes, go ahead.
I was just going to say, so you treat the 3x squared as y, but then I looked up and saw the function is y equals
3 to the x, yep.
3x.
So that's what the graph looks like. This is the graph of 3 to the x. That's an exponential function. Now, if that number was not 3, if it was a 2, it will have the same shape, but it will not be as steep as that one. If it was a 2, it will look like this. Still going to go through 0, 1. That will be 2 to the x. If the number was 4 to the x, would that be steeper? It will be steeper. So if that was 4 to the x, it will look like this. It rises faster and falls faster. It never goes below the x-axis. That's what the graph will look like. But they all have the same shape. If it was 1 to the x, what does the graph will look like?
It will be constant.
Yep. 1 to any power is what? 1. That would be just a flat line like this. It won't be exponential. So it can't be 1. If it was a negative value, it will not even be exponential. Because when the exponent is odd, it's going to be a negative number. When it's even, it's going to be what? Positive. So it's going like this, zigzagging. So that number can't be a negative number, because if it is, we got a problem. It's not an exponential function. If any of you have kids, and I know you guys older, so you probably have kids. When your kids were young and took them to a doctor, you have that. My kids, we had that green book to keep track of their health. Do they still give you that one?
Yeah.
You can look and see their weight and height. It's always exponentially. Then it levels. After a while, because you don't keep getting taller and taller, it levels. But it has exponential growth. It looks like it's actually reversed when it goes like this. You know, it's reversed to this. So if you have your kids' medical booklet, just look at it when you go home. You'll see actually looking like this, the graphs. And it goes, then it levels. It starts to grow exponentially when you're young. Then you reach a point you can't grow anymore. That's it. I mean, weight, we might gain a few pounds, but height and all the stuff, no, that's it. You level. So that's really the exponential portion when they were young. Then after a while, once you reach like 20, 21, your height doesn't change much. A few people actually end up changing that. Who's that basketball player, the center for the Falcons? Pelicans. He's like 6'9", just grew another inch, but he's only 22 years old over the summer. He's like 6'10" now. It was 6'10", now it's 6'11". But if you look at them, they do fit exponential. That's called growth problem. We grow, that way. So where do we use exponential function? Oh my goodness, we use them all over. I can tell you, most banks today, if you were to deposit money in the bank, they don't calculate the interest now like they used to do before. It used to be simple interest, meaning what? You put $1,000, you have $1,000 till, if you put $1,000 today in the bank, or years ago, if you put $1,000 in the bank, and you put them on January 10th, and you go to the bank on January 9th, and you go, what's my balance? They go 1,000. On January 10th, they calculate your interest and add it to your balance. So you don't get interest till you let it sit for a year. Simple interest, whatever the period is. So you don't get interest on the interest. Then they start changing that. They go, you know what, we should calculate the interest more often. And they start doing it every 3 months. Quarterly. Then they go, first that was semi-annual. Twice a year they calculate the interest. So your money doesn't get interest till the end of the month, till the end of 6 months. You get interest, your new balance becomes different. Because what happens if you put $1,000, let's say at 10%, let's still use the 10%. And it still sits for 6 months. Now at the end of 6 months, you will have interest equals principal times rate times time. Your principal is the $1,000 that you put in, the rate is 10%, and the time is half a year. You'll get $50 of interest. 6 months in 1 day, your balance is not just 1,000, it becomes what? 1,050. And we thought that was good. They're giving us interest every 6 months. Then they went every 3 months. Then it became weekly, monthly, weekly, daily. Now it's continuous. Continuous. And the equation banks will use today to calculate the interest on your money is this equation. The amount of money you will have is your initial deposit, e to the power of r times t. A0 is the initial deposit. R is the interest rate. T is the time in years. Well, time in years, like if you put it for a month, you got to go 1/12, And A0 is the initial deposit. That's an exponential function. Anyone knows what E is?
Constant.
Yeah, E is one of those crazy numbers like pi. It's on your calculator. E is equal to roughly 2.71828, I think. It's one of those crazy numbers. Every calculator has that right on top of ln. Find where the ln key, right there. Can you see my calculator on the screen? E is directly above it. So you know what E is? You go, what is e to the power of 1? E to the 1. What is that? 2.718281828. Some crazy number. Yep. That's used in finance. That's used in forensic science. When we find a dead body in the room, trying to find how long the person been dead, we use that based on the temperature of the body when you find it. If the temperature of the body is above room temperature, that person been dead just for a few hours. Depends how cold. If the room is 70 degrees and the body is like, if you're healthy, what's your body temperature? 98. So if they walk in and take your temperature, somebody's dead, and let's not kill you. They take the temperature, it's 90 degrees. You've been dead for a few, maybe an hour. But if the room is 70 degrees, they come in, the temperature is 72. Oh, we can pinpoint how long it takes. There's an equation for that. But after a while, what happens? Your body temperature becomes what? 70 degrees. So if somebody's been killed for a week in this room, the temperature stays whatever the room temperature, surrounding temperature. So temperature is no longer a factor. They can't use temperature. We have to use something else. They start looking for, do we have any maggots there on the body? And based on that, they can tell. I'm taking to a wonderful subject, huh? But in forensic science, we use that. In finance, we use that. In chemistry, we use that. In physics, we use that. We use E all the time. You're going to see it's used a lot. That's why there's a button for that, just like pi. So going back here, just to get you all upset now, and I've done this talking to senior citizens because a friend of mine does work with a senior citizen. I have to go twice a year and talk to them, and usually the same subject about money. I like to get them all mad. And I said to them, how many of you have money in the retirement? They all raised their hand. And I go, okay, how much are you paying them? They go, well, it's 1%, 1.5%. Usually when you give your money to, let's say, Merrill Lynch to invest it for you, they'll go, we're not going to take money from you. We'll take 1.5% of the profit we got to make. So that doesn't sound like a bad deal, but let's assume somebody young just inherited $300,000, or somebody been working, saved $300,000. And that person walks to Merrill Lynch, and the guy want to invest that money. Merrill Lynch says, I'll tell you what, we'll take 1.5% of, we do a good job. Because I said to him, go see Jack Danucci. Jack does a wonderful job. Go see him. He's going to get you some return on your money, 10, 12% probably, but he's going to take 1.5% of the money. So Jack takes the money, or Merrill Lynch takes the money, invests the money, and 20 years later, you go, you know what? Over the past 20 years, Jack was phenomenal. Let's say he managed to get 12% return.
So you keep 10.
So you're getting actually 10.5%. But let me show you the better numbers actually. So the amount of money, when you cash that investment, the amount of money Jack is going to collect, let's say they put him in the stock market, he's going to get the initial deposit, which is $300,000, e to the power, r is the interest rate, which is what, 0.12, and had it there for 20 years. If you take your calculator out, 0.12 times 20 is what? Is that 2.4?
Yes.
2.4. So let me go to my calculator and write that out. 300,000 times e to the power of 2.4. Ooh, I'm rich. 3,306,952.91.
See what senior citizens will be pissed.
That's what Merrill Lynch will get from, what is it, TD Waterhouse now, whatever it's called, the trade company, if they invest them. I forgot the name of it now. Oh, wait a minute. Merrill Lynch is going to steal. Remember the deal we said we're going to take 1.5%? You are actually going to get what? Not 12%. You said what? 10.5%.
Yeah.
So your money is going to be 300,000 e to the power 10.5. That's 0.105 times 20 years. That's 10.5%.
Which is
2 is it 2.1?
2.0.
2.1, I think. Is that 2.1?
Yes.
So let's see what that number, 300,000 e to the power of 2.1. Oh, I said that, I'm going to give you a check today of $2,449,850.97.
So how they end up with more money than you?
they're gonna get about $1 million, close to $1 million. That's what they collected. From that, they're gonna pay me that.
Oh, okay.
They collected that money because they get 12% return. Now they're gonna turn around and pay me that, and their portion.
Is $1 million.
Yep.
No, like $900,000.
Is gonna be 3,306,952.91 minus 2,449,850.97.
So does
Three.
tax come out before or after?
After you get your money.
After you get, and that's
Each one paid their own.
No, this is not too bad.
it's like a lot of taxes.
So that down to like
1.2 million. Yeah.
Over 20 years.
I think it's crazy how they can.
Just get away with that.
857,101.94 That's what Merrill Lynch will get from your investment.
And then IRS takes taxes out of all things.
Well, you're paying. I mean, I'm sure it's not great rates, but you're paying them for 20 years worth of
Service, yeah.
in service.
Yeah.
So for an investment company.
I can tell you, if you did it yourself, you're not going to get the 12%. Yep. But people don't see that. They go, he took $4 million from my money. That's a small amount, by the way, for a retiree. If that's all you got when you retire. If you don't have Social Security, that's your retirement. $300,000 doesn't last you that long.
Depends where you live.
Even you go for Florida.
where you live, Tent City with that much money?
Texas, I mean, Mexico. That goes a long way to Mexico.
I can, start planting some stuff there, growing some stuff, and shipping it with my. No, never mind. I'm on video. Great, wonderful. I'm out of a job now. But that's how exponential functions work. Not a straight line. But we use E a lot. If you look at the assignment, we really deal with E all the time. You'll see it all over, not just in these examples. I just want to show you. But that's what the banks use today, by the way. Remember that example quickly? I said your money will double every 7 years. So it's not really 7 years, it's 6.93 years. If you actually did the math to see how much money, if they did it compound continuously, I'm going to have more than 20.4 million. I'll probably have about 21 million or 22 million because that 0.93, we're leaving out 0.07 years every time because your money doubles every 2.93 years. I'm stretching until 7, but if you did the math on that, you go 5,000 e to the power, interest rate, we said 10%, times how many years? 84 years. So you'll have 5,000 e to the power of 8.4, and you'll see that number is a little bit higher than 20.48 million.
Man, I wish my parents
Did something?
did math.
See, when you learned this, were you kind of mad that you didn't do it?
Well, just like the rest of us, this is actually 22 million. My parents couldn't even afford to feed us, So you're saying, where's people going to come up with the money? So if you can't do it, you can't do it, So, but notice it's 22,235,000. That's a little bit more than 20 million because of the 0.07 every year. That's extra time. So basically take 0.07, 0.07, 0.07 every 7 years. That adds up to about a year and a half. So if you take that money for a year and a half, you get another million out of it.
Can we do it when we account for inflation?
You got to figure out what the inflation rate.
3%?
Well, if the inflation 3% every year, then you got to deduct that.
3% out.
Deduct 3% from the 10%, you're down to 7%. So if you do that, actually one thing, if I can give you one advice there, just look at these numbers. See, if you do 28 years, 80,000. If you do 21 years, 40,000. What am I trying to tell you? Don't wait too long to put money into retirement. If you wait till your age of 40, you're only going to have about 20 years to put money. I don't care how much you put. It's not going to add up. If you start young at age 18, 19, putting $100, you'll have $1 million easily. $100 a month, you will have over $1 million by the time you are age 60, 65.
Just leaving it in the bank.
Just well in the bank.
Right.
Just put in the stock, find the stock and put it in the stock.
That's right.
Yeah, bank is gonna give you 0.5%. Good luck.
Unless, like, the company
Yep.
has a random first and